Yeah, hello out there. This is a very interesting topic in physics. Before we proceed, we are discussing there are three major things: a galvanometer, an ammeter, and a voltmeter. Before we proceed with this, you must understand the basics. And a galvanometer measures current, while an ammeter also measures current. So what's the difference between them? This one is more sensitive, a galvanometer. It can measure small amount of current that the ammeter cannot detect. So a galvanometer is more sensitive than an ammeter. So the current that will pass through an ammeter, if you pass through a galvanometer, it will burn it. It's not designed to take so large amount of current. For voltmeter measures either the EMF of the cell or the potential difference. Some other time, I'm going to tell you the difference between the EMF of the cell and the potential difference. So let's just what happen here. This is what we do. Let's say this number one. Here is the diagram. This galvanometer, let's call it G, goes like that. You bring something like this. You put something here, we call it shunt. So the galvanometer has the resistance of galvanometer, let's call it RG. Resistance of the galvanometer is 50 ohms. As a full-scale deflection for a current of 5 milliamperes. So the current going through the galvanometer is 5 milliamperes. So 5 milliamperes is same thing as converting this to ammeter, because 1000 milliampere is equal to 1 ampere. So 5 milliampere will give you 5 divided by 1000, and this will be ampere. That is 0.005 amperes. So here, the resistance of the galvanometer here, G is for galvanometer, is 50 ohms, and the current through the galvanometer, IG, is 0.005 amperes. Now, how do we now use, that is the maximum current that this instrument can measure, 0.005 amperes. But we want it to read up to 10 amperes. So the current is coming from here, the current is 10 amperes. If the current is allowed to go all through, it will burn this galvanometer. So what happens is that you connect a low resistance shunt in parallel with the galvanometer. What do I mean? So out of these 10 amperes, at this junction, the one that will go here will be 0.005 amperes. The balance will be deflected towards the shunt. Now let us see what we have. The one that will go through the shunt now, if you deduct this from this, you're going to get 9.095. Is that correct? 10.000 by 0.005. This is 95. This is 5, 9, 9, and 9. Yes, this is 9.995. 9.995. It means that the current that will go through the shunt will be the current through the shunt. S for shunt is 9.995 amperes. So let me explain what we have just done. This galvanometer can only take the maximum of 5 milliampere, which is the same thing as 0.005 amperes. But we want to measure a current up to 10 amperes. How do you do that? We want to convert this galvanometer to an ammeter so that we're able to measure a large amount of current. So we divert the 0.005 amperes that this can measure, the maximum, you let it go. You now divert the balance of this 10 to this shunt. So you are now to find the resistance of the shunt. That's what we want to find out. Now let us see how we solve it. Because the galvanometer and the shunt are in parallel, electrical devices in parallel, they have the same PD or potential difference. That is, the potential difference of the galvanometer is the same thing, potential difference of the shunt, because they are in parallel. Now, but potential difference is equal to IR. So the potential difference of the galvanometer, we can use IR to replace it. That is, IR is equal to that of the shunt is also IR. But to differentiate between them, we put G here for the galvanometer, and put S here and S here for the shunt. The job is done. Now, what's the current flowing through the galvanometer? It is 0.05 times resistance of the galvanometer. That is what? 50. Then is equal to current going through the shunt is 9.995. Then times resistance of the shunt. So the resistance of the shunt will be equal to 0.005 times 50, all divided by 9.995. Now let's just check the calculator for the answer to that one. And you see that the resistance will be very low. So to convert a galvanometer to an ammeter, you always connect a low resistance in parallel to the shunt. This is 0.005 times 50, then divided by 9.995. So the answer, the resistance of the shunt will be 0.025 ohms. And that is how to solve it. We have now converted this galvanometer meant to measure small amount of current to an ammeter which can measure a large amount of current by simply connecting a low resistance shunt in parallel to the galvanometer. That is the first part of the question. It's as simple as that. Now, we're now going to see how to solve the second part. Naturally, galvanometer measures current. We're going to convert to measure EMF or potential difference. How do you do that? Theoretically, what you do is that we connect a high resistance multiplier in series with galvanometer. But how did it play out? Let me show you another end how we go about it. Now, this is what you see. Let's say this is galvanometer. This is galvanometer. You now put a multiplier here. Let's call this a multiplier. So this is what you do. Here, because they are in series, you have, this is the PD of the galvanometer, will be here, and here we have the PD of the multiplier, just like that. Then across all, we have the PD across both of them. From what we have seen, it means the general PD would be PD of the galvanometer plus the PD of the multiplier. As you can see, if from here to here is VG, from here to here is VM, then from here to here will be VG plus VM. But like we said here, the V will be equal to, we set this equal to IR, so V will be current of the galvanometer multiplied by the resistance of the galvanometer plus the current going through the multiplier, then times the resistance of the galvanometer. That's what we see. But there's one interesting thing here that you should put in mind. Permit me a minute, let me rub this place so that we'll continue from here for you to be able to see what we are doing. We do want to manage space for your sake. Now, you discover that these two are in series. So the current that goes through the galvanometer will also go through the multiplier. That means the current of the galvanometer is the same thing as the current of the multiplier. because two electrical devices in series, they have the same current. So we can now remove G and M from here because they are the same, no difference between them. So this should be Rm for the multiplier. So what is the total voltage you want to measure? To a voltmeter ranging up to 10 volts. So it means our V, we said V is equals to IRG plus IRM. We did not put G or M here because they are the same. So we want to measure 10 volts. We put 10 here for V. What is the current flowing through? The current flowing through the galvanometer is 5 milliamperes, which we have done. That is equal to 0.005 times resistance of the galvanometer. It is 50, then plus the same current is flowing through them, 0.005 times resistance of the multiplier, which we want to find. Now this will be 10 is equal to, multiply this by this, 0.05, let us check the calculator, 0.05 times 50, and see what we have. That is 0.05 times 50. Sorry, 0.005 times 50. That is 0.25. This alone will give us 0.25. Then plus this time, this will give you 0.005 Rn. You can now correct like times. Bring this to the other side here. You have 10 becomes minus 0.25 is equals to 0.005 Rn. So 10 minus this, you get 9.75 is equals to 0.005 Rn. So the resistance of multiplier will now be Rn equals to 9.75 all divided by 0.005. So the resistance of the multiplier will give you, let's check, 9.75 divided by 0.005. And that is 1,950 ohms. That is all. It's not more than that. So in theory, if they ask you that how do you convert a galvanometer to an ammeter, you just respond that you do that by connecting a low resistance shunt in parallel with the galvanometer. And if they ask you how do you convert a galvanometer to a voltmeter, the answer is simply you connect a high resistance multiplier in series with the galvanometer. If you check through, it's as simple as ABC. At Momentum Minds again, we have shown you something special in physics, which we think you should read. Go to our YouTube channel, Momentum Minds FS, you subscribe to it, and we let you into a lot of secrets about physics and how to pass it. Until we meet next time, do have a nice day. Bye.